Good afternoon. My name is Gabriel Aviles Cordero of the Biomedical Engineering Department, and I'm going to be presenting my phase C.2 of Capstone 2. The title is Continuous Passive Motion Device Mechanical Subsystem by Gabriel Aviles Cordero and Professor Dr. Carlos Alvarado. The presentation outline starts by the system integration plan, manufacturing and integration or assembly plans, and the procedures, system operation plans, performance estimates, project plan, and subsystems budget. Here you can see pictures or images or figures of the system integration plans. As you can see, we have a front view, a back view, and a left view and a top view of the CPM device. Our machine is composed of two subsystems, the mechanical system or mechanism systems and structure system. The purpose of both systems is to facilitate movement and arrange a predestinated range of movements. Next, we're going to keep talking about our system integration plan. Firstly, for our ankle subsystem or ankle mechanical system, we can see a figure showing our free body diagram in which we denote the angle of displacement, the output angular velocity, the output torque, the input torque, and the angular velocity of the input. In our known metrics values, we have the input torque of 20 Newton meters, a type gear, which is a bevel gear, and input power, which is 100 watts. A driver teeth numbers or driver gear teeth numbers will be 19 teeth. The range of movement should be 80 degrees, and the angular input velocity should be 3 RPMs. As mentioned previously in our C1 phase, we then identify our unknown metric values and calculate the results. And we obtain an unknown value of an output torque of 25.26 Newton meters, a driven gear number of 24 teeth, and output angular velocity of 2.37 RPMs. Now, continuing our system integration plan for our knee mechanical system or our pulley mechanical system, we can also see a free body diagram which will represent the belt velocity, the input torque, the central distance between the two pulleys, the output torque, the output angular velocity, the pulley diameters, and the angular velocity of the input. As same with the ankle system, mechanical system, we have calculated our unknown in phase C1, which are our known are inlet torque or input torque, input angular velocity, input power, driver pulley diameter, output angular velocity, output torques, and central distance. The values in the same order are 16 Newton meters, 1000 RPMs, 10 Newton meters, 100 watts, driver pulley diameter 1.18 inches, output velocity 400 RPMs, output torque 150 Newton meters, and the central distance, as mentioned, 5 inches. Our unknowns are the belt length of about 10 inches, contact angle of 30 degrees, a driven pulley diameter of 2.95 inches, and a bell speed of 32.38 inches per second. Now, we're going to talk about our manufacturing and integration structure subsystems, starting with our bill of material. In this slide, we can see both a hidden lines diagram or a figure or drawing of our subsystems, and in the right, we can see a structure with shades and lines, solid lines of the CPM or subsystems trying to be designed. In our bill of material, we have a total of 17 items. Starting with the base, then going to the upper link, mid link, lower link, upper internal link, mid internal link, footrest, a driver pulley, driven pulley, a pulley belt, a primary LED link, secondary LED link, a driven gear, a driver gear, a gearbox case, a LED bar, and a mechanical base mid link. For all of this, we have a quantity of one base, a quantity of one footrest, a quantity of one driver pulley, a quantity of one driven pulley, and a quantity of one gear. Also, we have a quantity of one gearbox case and one LED bar. The rest of the parts are in quantity of 2 parts. If we're gonna go in the next slide, we're gonna see our drawings and measurements starting for the base. In the right, we can see our manufacturing step process, and in the left, we can see our drawings and specifications. Next, we have the drawing specification and manufacturing process of the driven gear, followed by the gearbox case, followed by the driven gear. Next, we have a specification drawings and the process manufacturing of the main LED link, followed by the pulley belt, followed by the mechanism and base link. Then we can see this secondary LED links specification and drawings and manufacturing process, the driven pulley process and manufacturing process and drawings, driver pulleys manufacturing process and drawings, the footrest process and drawings, the left mid internal link, right mid internal link, upper internal link, lower internal link, mid link, upper link, and that will be all the specifications and drawings and manufacturing process of all the assembly and parts of our subsystems of mechanical systems. Once we finish with our manufacturing and integration plans, we then go to our systems operation plans or our user manuals. The first instruction is to turn on the equipment system. To do this, locate the power button on the device controller. Press the button on power on the device. Once started, let the device rest and prepare for its usage. Second step, turning off the equipment system. Locate the power button on the device controller. Press the button to power off the device. Third step, patient placement. Patients or device users must first take place in the appropriate area as denoted in the user manual. Always follow safety precautions. Fourth, start motion cycle. Locate and press the start button to commence the rehabilitation process. Fifth step, end process. Press the end button to end the rehabilitation process and for the patient to move out of the device. Sixth and last step, maintenance. Checks for spills and liquid in the perimeter. Dry every liquid found. Maintenance requires a general overhaul of 1,000 hours depending on usage. Check periodically that every connections are corrected so that the device works properly. In the next slide, we can see the system operation plan of the motion cycles of the device. The first figure is demonstrating an initial or resting position. This is a position that the patient will find the device before starting the cycles. Then we see the cycle first phase. Once you press the start button, the device is going to follow and open the knee up to 150 degrees. The same will be to the ankle up to 80 degrees. Lastly, the last phase is the device is making a complete flexion of the knees and a complete plantar flexion of the ankle. The next slide, we're going to talk about our CSIS MOPs of measurements of performance. Our measurements of performance are based on the mechanical system proposed in phase C.1, in which our torque output knee should be about 130 newtons per meter. It was specified in phase B, and to this day it complies. Torque output ankle 40 newtons meter. Range of movement, the knee have 2 and the ankle have 2. 150 degrees max for the ankle, 80 degrees max for the 150 degrees max for the knee, 80 degrees max for the ankle. A motor power of the knee should be 100 watts, and the motor velocity should be 1,000 RPMs. Bevel gear fits should be 19. Operational weight should not be more than 8 kilograms. Operational temperature between 30 and 40 degrees Celsius. Investment cost for the knees $120. For the ankle, 193, and for the knee, 420. Sorry for the error. Range of movement should be, as mentioned previously, 150 degrees for knees and 80 degrees for ankle. Every MOP is completed and is in compliance with the stipulated as shown previously. Next, our budget for the mechanical subsystem. We have a driver gear that costs around $26, a driver gear that costs $20, a driven pulley that costs $18, and a driver pulley that costs $18. All of them are bought and are manufactured by Alibaba. The ankle motor case is a self-made by the team, and the parts cost are roughly $50. Ankle motor by GBL costs $193. A knee motor by Kneework costs $400, with a total of $543 of the in total investment cost. Lastly, we can see our project plan for phase D, in which we have a stipulated date of the 17th of May of 2022. Thank you for all your attention, and I hope this presentation is of good uses for all of you.